All right, this is contemporary mapping, and this can also be called geospatial data. It includes all information that can be tied to a specific place. This is the one where a lot of these we're really familiar with. The best locations, such as mountains, roads, or boundaries. It includes human activities and traits. Um, for example, where do Chinese speakers live? How common is poverty in the US? Most geospatial data is gathered in the field, and this means that the data was observed and recorded on location, and the collecting is known as field work. All right. Sources of these types of data can come from a census of population, that's just counting the number of people in the population, interviews, informal observations made by geographers, land surveys, photography. Um, these are all important when you're using this data, and technology is making the collection, the accuracy, the storage, the analysis, and display of geospatial data easily. And then sometimes in layering, when we talk about GIS, we'll talk about how they use all of these things, and then they put it on top of each other, and then they can get land values, what they might want to build there, depending on what the land is like.
Yep. Okay, so we've got some different types of contemporary tools. We're going to hold you guys responsible for 3 types of geospatial technologies. The first one up here, this is an image of remote sensing, and I know it's a pretty elementary image, but it gives you an idea essentially of what is being done when remote sensing is taking place. So this is one of our tools. The use of remote sensing then is cameras or sensors that are mounted on aircraft, and you can see that image up here, either on aircraft or satellites. And what they're doing is they're actually collecting digital images from the Earth's surface. So you guys can see right here in this example, you've got the sun that is heating vegetation, and then what those sensors are actually doing is it is detecting those vegetation changes, the heat change on the Earth's surface. Then these satellites or these airplanes that capture the data and the different bands, they are detecting then these features from the physical environment. They may also be using then signals such as a GPS. So why would you use remote sensing? You might use it just to basically understand how land is being used. So what is land covered with? Is it covered by vegetation, by humans, etc.? You might use remote sensing to monitor environmental changes or assess the speed of spatial changes and phenomena. So how are things changing? You might use remote sensing to look at weather patterns. Remote sensing then is going to be one of the tools then that we will talk about, which is used down here in GIS.
And also with remote sensing, you could use when they're looking at the polar ice caps, they're looking to see how much they melted, and then they compare those photos months or years apart, and they can see the damage. The second one that we're going to look at, this is the one we're probably really familiar with, is GPS. This is a global positioning system. GPS receivers on the Earth's surface, they use the location of multiple satellites, and they determine and record a receiver's exact location. Exact is important there. This is where you would use longitude and latitude. These satellites broadcast location and distance to handheld receivers, such as your phone. It could be in your car. Most cars come with these now. And they become a mathematical tool for longitude and latitude and also direction. What do we use these for? Well, most people use GPS to figure out how to get from one place to another. It takes the recording of mathematical location, that's your longitude and latitude. It precisely locates the borders. Ships use it for navigation, aircrafts, once again, cars, as I mentioned, and then map making lines, trails, or points like fire hydrants can also be put on there. If you look in your book at the chloropleth outbreak in England, it pinpoints exactly what water pump caused that cholera outbreak.
Yep. All right. So these are 2 tools. Now I want you to think of GIS. My brother is a GIS engineer, and he always explains it to me like an umbrella. The GIS is the umbrella, and then underneath that that comes some of these other tools that we are familiar with. So what is GIS, or Geographic Information Systems? You can use it really as a noun, or you can use it as a verb. So GIS, it's a system, it's a computer software system. But it can also be, I am in the field of GIS, which is making maps using sophisticated tools. So what is it? It's a computer system that not only is where you input data using remote sensing and your GPS. So you take those coordinates, you take whatever data you're collecting, you input it into this computer software program. From there, you can analyze it, manipulate it, distort it, and then display the information in the form of a map. So it's cartography, or using geospatial data sets. So this umbrella then, again, using a GPS, using remote sensing, using that data collection and then storing it and manipulating it in your computer software system. What's so cool about GIS then is you can take this data that you have gathered, whether that data is topography or the Earth's surface, or that data is income levels of certain people in an area, or that data is vegetation of people or land masses in that area. You can use that data, and then what the really sophisticated computer software program will allow you to do is actually layer that data on top of each other, creating a map or cartography, right? This map that is really unlike any map you could see before, which has then these different layers and images on top of each other, which creates, again, a really accurate representation of a certain place on Earth's surface. So using that to make really, really sophisticated decisions about Earth's surface. You can use GIS for a number of things. People can analyze crime data using GIS, looking at crime rates in a certain area, and then you could layer ethnicity, you could layer income into crime data as well. The effects of pollution, transportation and travel time. My brother works for Warner Enterprise, so he works for the trucking company, and they are in the industry of transporting goods for certain companies. So using a GIS software program, he can actually tell you in real time where his truck is everywhere in the United States, how far away they are from someone. They have a road map, which is a reference map like we talked about, which shows you the accurate distance and location, and using it for transportation. Many businesses today, if they are in the field of trading or selling their goods, they're going to hire people in GIS to help them in their transportation time. And then urban planning, we talked about that already a little bit here. If I want to locate a new store, or if I want to locate, let's say, a high-end clothing design, I might tap into an urban planner who has access to GIS to tell me, okay, let's layer these different characteristics. Let's layer income level. Let's layer that on top of average age. Let's layer that on top of topography. Let's layer all these things. And then I can see on a map here, pinpointed right here, is the best location for my new industry. Maybe one of those layers is, where are all the other Macy's or department stores located here around this area? And using these geospatial data tools, or these contemporary tools, we really can just make way better decisions about our routines throughout our world, but also for industry, business, climate, environment, all of the above. It's just really revolutionized the way that we understand maps.